James Webb Update. There's a problem with the telescope. The James Webb Space Telescope has been designed to answer many of the core questions that have animated astronomers over the past half-century. With a $10 billion price tag, it is one of the most ambitious engineering initiatives ever attempted. But for it to achieve its potential, nothing less than to rewrite the history of the cosmos and reshape humanity's position within it, a lot of things have to work just right. So, is James Webb actually working perfectly, or are the rumored problems actually true? Let's find out. Welcome to Space World. In today's video, we are going to talk about an update on James Webb Telescope, according to which there's a problem with it. So if you want to know more about it, then stay with us until the end of the video. Exploring strange new worlds, understanding the origins of the universe, searching for life in the galaxy. These are not the plot of a new science fiction movie, but the mission objectives of the James Webb Space Telescope, the long-awaited successor to the Hubble Space Telescope. However, there have been news about the Space Observatory suffering from minor problems. According to sources, the James Webb is currently experiencing problems with its MIRI instrument. The problem is due to increased friction in one of the MIRI's mechanisms in the medium-resolution spectroscopy (MRS) mode. The observatory is otherwise healthy, but the team decided to stop observations using MRS mode until they find a solution. JWST's mid-infrared instrument, MIRI, is one of the most important instruments on board. It allows the telescope to see in the wavelength range from 5 to 27 micrometers. The instrument has 4 modes: imaging, medium-resolution spectroscopy, low-resolution spectroscopy, and coronagraphy. On August 4, during preparation for observations using MIRI's medium-resolution spectroscopy mode, MRS, the team detected a problem with the grading wheel. Its function is to select between short, medium, and longer wavelengths. During the setup process leading to scientific observation, the telescope detected increased friction in the mechanism, which caused the issue. Following preliminary health checks, an anomaly review board was convened on September 6 to assess the best path forward. As a result, JWST paused observations in the MRS mode using MIRI until an adequate solution is found. 3 remaining modes of MIRI are still working properly. Other instruments aren't affected either. So now that we know the problem is not a serious one, let's take a look at some of the previous problems with James Webb. It's not the first time that James Webb experiences issues since its launch in December 2021. Previously, a larger-than-expected micrometeoroid hit one of the JWST's mirror segments. There was enough damage to be detected by the team, but the quality of observations is still exceeding original expectations. Despite the current issues, we should still expect new images to come. So, recent releases of the Tarantula Nebula and the Orion Nebula definitely won't be the last. There are many other modes the observatory can use for now. Besides, there are a lot of things that James Webb already observed but did not release to the public yet, like the images of the TRAPPIST-1 system, which it took during the first month of scientific operation. Hopefully, the team will be able to find a solution to the current issue and return the telescope into fully functioning mode. Apart from these issues, astronomers have been so keen to use the new James Webb Space Telescope that some have gotten a little ahead of themselves. Many started analyzing Webb data right after the first batch was released on 14 July and quickly posted their results on preprint servers, but are now having to revise them. It has been revealed that the telescope's detectors had not been calibrated thoroughly when the first data were made available, and that fact slipped past some astronomers in their excitement. The revisions don't so far appear to substantially change many of the exciting early results, such as the discovery of a number of candidates for the most distant galaxy ever spotted. But the ongoing calibration process is forcing astronomers to reckon with the limitations of early data from Webb. Figuring out how to redo the work is thorny and annoying, says Marco Castellano, an astronomer at the Italian National Institute of Astrophysics in Rome. There's been a lot of frustration, says Garth Illingworth, an astronomer at the University of California, Santa Cruz. I don't think anybody really expected this to be as big an issue as it's becoming, adds Guido Roberts-Borsani, an astronomer at the University of California, Los Angeles. Calibration is particularly challenging for projects that require precise measurements of the brightness of astronomical objects, such as faint, faraway galaxies. For several weeks, some astronomers have been cobbling together workarounds so that they can continue their analyses. The next official round of updates to Webb's calibrations are expected in the coming weeks from the Space Telescope Science Institute, STS-CI, in Baltimore, Maryland, which operates the telescope. Those updates should shrink the error bars on the telescope's calibrations from the tens of percentage points that have been bedeviling astronomers in some areas down to just a few percentage points. And data accuracy will continue to improve as calibration efforts proceed over the coming months. Adding to this, the STS-CI made it clear that the initial calibrations to the telescope were rough, says Jane Rigby, operations project scientist for Webb at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Much of the issue stems from the fact that Webb, which launched in December 2021, is a new telescope whose details are still being worked out. It's been a long time since the community has had a brand new telescope in space, a big one with these amazingly transformative powers, Rigby says. All telescopes need to be calibrated. This is usually done by observing a well-understood star such as Vega, a prominent star in the night sky. Astronomers look at the data being collected by the telescope's various instruments, such as the brightness of the star in different wavelengths of light, and compare them with measurements of the same star from other telescopes and of laboratory standards. Therefore, working with Webb data involves several types of calibration, but the current controversy is around one of the telescope's main instruments, its near-infrared camera, NIRCam. In the 6 months after Webb launched, STS-CI researchers worked to calibrate NIRCam. But given the demands on Webb, they had only enough time to point it at 1 or 2 calibration stars, and to take data using just one of NIRCam's 10 detectors. They then estimated the calibrations for the other 9 detectors. Within days of the first Webb data release, non-peer-reviewed papers began appearing on the arXiv preprint server, reporting multiple candidates for the most distant galaxy ever recorded. These studies relied on the brightness of distant objects measured with Webb at various wavelengths. Then, on 29 July, the STS-CI released an updated set of calibrations that were substantially different from what astronomers had been working with. This caused a little bit of a panic, says Nathan Adams, an astronomer at the University of Manchester, UK, who along with his colleagues pointed out the problem in a 9 August update to a preprint they had posted in late July. For those, including myself, who had written a paper within the first 2 weeks, it was a bit of, oh no, is everything that we've done wrong? Does it all need to go in the bin? Now, to try to standardize all the measurements, the STS-CI is working through a detailed plan to point Webb at several types of well-understood star and observe them with every detector and every mode for every instrument on the telescope. It just takes a while, says Carl Gordon, an astronomer at the STS-CI, who helps lead the effort. In the meantime, astronomers have been reworking manuscripts that describe distant galaxies on the basis of Webb data. Many of the most exciting distant galaxy candidates still seem to be at or near the distance originally estimated. But other preliminary studies, such as those that draw conclusions about the early universe by comparing large numbers of faint galaxies, might not stand the test of time. Other fields of research, such as planetary studies, are not affected as much because they depend less on these preliminary brightness measurements. We've come to realize how much this data processing is an ongoing and developing situation, just because the observatory is so new and so young, says Gabriel Brammer, an astronomer at the University of Copenhagen, who has been developing Webb calibrations independent of the STS-CI. So in the long run, astronomers are sure to sort out the calibration and become more confident in their conclusions. But for now, scientists need to work with caution, because whatever results they might be getting today might not be quite right in 6 months when they have more information. It's just sort of proceed at your own risk. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. And also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.